On example number 1, these denominators do not factor, so we don't have to worry about that. But we do have to worry about what the denominators do not equal. The denominator cannot be equal to 0. The denominators cannot be equal to 0. So, add 5 to both of those sides. X cannot be equal to 5. Add 3. X cannot be equal to 3/2. So now we know what X is not equal to. So now we're going to solve for X. So up here, we're going to get rid of the denominators. I am going to multiply both sides of the equation by X minus 5. Where did I get this X minus 5? There's the first denominator. I multiply it so that I can cancel out that first denominator. So those cancel out, and I have 4. This 4 over here distributes. Then I multiply both sides of my equation by 2x minus 3 so that this denominator can cancel. Over here on this side, I distribute. I'm solving for x, so I need to get the x's together. Subtract the 4x from both sides of the equation to zero that part out. 4x minus 12 equals negative 20. Add 12 to both sides. 4x equals negative 8. Then what am I going to do with the 4? And that's going to cancel, and x is going to be equal to negative 2. Now, does this contradict what I wrote there? No, it's fine. And so there are no extraneous answers in this example. First step is to factor the denominator. The next step is to find out what x cannot be equal to, because the denominators cannot be equal to 0. Then I need to cancel the denominators. So I'm going to multiply x plus 1. I'm going to multiply x plus 1 by every single term. If I have 3 terms, I'm going to multiply x plus 1 3 times. And this x plus 1 is going to cancel. This x plus 1 is going to distribute. And this 2 is going to distribute. I still have a denominator. So now I'm going to multiply all 3 of my terms by x minus 2. And you need those parentheses in there so that your problem will be mathematically accurate. This x minus 2 cancels that x minus 2. This distributes x squared minus 2x. That canceled out. What do I do with this? This needs to be multiplied together by FOIL or a box problem. You will get the same answer whether you use FOIL or a box problem. I usually use a box problem because it's real easy to see if you leave out one of the terms. So this is going to be 2x squared x minus 4x minus 2. Whether you use a FOIL or a box problem, this is what you get when you multiply that binomial times that binomial. Now I need to solve for x. Over here I need to combine some like terms. This, is that right? Did I write that down right? Excuse me. Okay, right here when you distribute, this should have been a 2. So then when you multiply it, this should have been a, because I knew that wasn't coming out like I wanted it to. So this was supposed to be minus 4. Okay, now I got that fixed. Thank you. When you distribute that, that would have made that a 2. When you FOILed that, that would have made that a 4. I still need to combine like terms. Subtract 2x squared from both sides. What's going to happen to my 2x squareds? Cancel here. What's going to happen over here also? Do I have x squared anymore? No, it canceled out. So now I need to combine like terms again. And x will equal to negative 4. Does this contradict anything there? This does not contradict what x cannot be equal to, so there are no extraneous answers. Now, just to help you understand what I mean, suppose I had a different problem, and suppose that I solved it all out and I came out with that was my answer. But this was what x cannot be equal to. Can x equal to and x not equal to at the same time? That would be a contradiction, and so when that happens, this would not be a solution, it would be an extraneous answer. Now that's not the problem we had, but just to help you remember what an extraneous answer is. On example number 3, the first step is to factor the denominator. Do you remember how to factor x squared minus 1? 1 is a perfect square number. That factors into x plus 1, x minus 1. So the first step is to factor this denominator into x plus 1, x minus 1. Now, I had told you previously, just so you would have some place to start, to multiply by the first denominator. And you would get to the same answer in the end. But if you multiply by the biggest denominator, you get to the same place with fewer steps. I could multiply everything by x minus 1. And then I can multiply everything by x plus 1. But if I multiply by the biggest denominator, let's see what happens. And you multiply all three terms. Then the x minus 1 cancels the x minus 1. The x plus 1 cancels the x plus 1, and all of that cancels out. By multiplying by the biggest denominator, I cancel out all of the denominators in one step instead of two. So to distribute the 1, distribute the 4. Let's see if I can distribute the 4 correctly. Combine like terms. These go together. These go together. Add 3 to both sides. Divide by 5. And the answer is x equal 2. X cannot equal 1. X cannot equal to negative 1. When I taught you to solve these, I asked you to multiply all three terms by the first denominator to give you a place to start. The more traditional way to do this is to teach you to multiply by the least common denominator. Now, the reason I didn't teach it that way is because we weren't very good at least common denominators. But let's do this problem using the least common denominator. The least common denominator would be 3x squared. If I multiply by 3x squared, the x's cancel. In this term, the 3's cancel. In this term, the x squareds cancel. And so I would have 3x plus x squared equals 18. Isn't that what you got when you multiplied first of all by an x, second of all by a 3, third time by a negative x? You can get to the same place canceling one denominator at a time. You can get to that same place shorter by multiplying by the least common denominator. So you can solve it either way, you'll get to the same place. Now once you're at this place, now what do you do? Do you see right here that x is squared? If x is squared, this is a quadratic equation. To solve a quadratic equation, it has to be equal to 0. And it has to be in standard form. To solve a quadratic equation, after you have it equal to 0, it's in standard form, you multiply the first number times the last number, and you write down the factors of negative 18. Could any of those factors add up to equal a positive 3? If and only if this is a 1, you can use the shortcut factoring. Does that imply to you that if this is not a 1, I cannot use the shortcut? That is what it should imply to you. If this is not a 1, you cannot use shortcut factoring. Since this is a 1, I can use shortcut factoring. And x minus 3 equals 0, and x plus 6 equals 0. And when I solve those two equations, I get x equals 3 and x equals negative 6. That does not contradict this, so there is no extraneous solution.